Hi guys, today I'm going to do a quick video about soldering. That's electronic soldering and some of the slightly larger joints that you might do when you're soldering. But let's just get underway and check out some of the tools and the items I'll be demonstrating today. Okay, so here we have the simple soldering iron. This is typical of the simplest soldering irons you'll normally use in the market nowadays. This has got 2.3mm tip on the end here. It's got a little hanging hook. This is my old favourite. I've had this for many years. It's good for smaller work, good for PCB work. It is not temperature controlled, so it's a little bit limited, let's call it, for what modern people like nowadays. But in all honesty, it's not bad at all. I can still comfortably use it without any problems. It plugs straight into the UK mains. It's 240 volts fed. It's got a 3 amp fuse in there, but it takes about 18 watts. So really very little power, and that is one of its limitations. It is quite lacking in power for larger solder joints. We'll come back to that in a minute, but there's a simple look at a basic soldering iron. Probably some of the more basic solder irons that I would recommend nowadays. There are some cheaper, simpler ones with screw-in tips and things. I really don't like those. They tend to get stuck, and that can ruin your entire iron. Whereas this one, obviously, if you need to replace the tip, it just literally slides straight off the end here. It's just held in with a little friction. Anyway, there's your first soldering iron. Non-temperature controlled, straightforward iron. The Antex CS18, it's an 18 watt iron. That's what I would personally consider the minimum I would want to use today. Okay, so we're moving on now to the soldering iron or soldering station that I tend to use on a, well, nearly daily basis. This is my go-to nowadays. It's still a very cheap item. These can be picked up on eBay and the likes for probably under £30, $40. That would be an easy price to get these for. The main advantage for this is that you can adjust the temperature. That in itself isn't essential or a huge advantage. However, it has the advantage that you usually have a higher powered iron. So we've gone from an 18 watt iron up to 60 watts now. 60 watt iron, 3 times the amount of power, potentially a larger tip. In this case it's about the same. But the advantage is that you've got a lot more power in the iron. You can adjust the temperature should you wish to, although I tend to solder about 300, maybe 325 in centigrade. That's what, about 575 to 600 Fahrenheit for you lot. This does take up a lot more space on your desk though. Obviously you've got the power supply unit that plugs in. Again, it still plugs into the mains voltage. This time you've only got 24 volts going down to the tip, but you also have a temperature sensor in the tip now. So the temperature sensor down in the tip will help maintain the temperature off the tip far more accurately, and it'll also in general, an iron which is temperature controlled with a sensor at the tip is going to maintain its temperature much better and allow you to perform more consistent soldering. The higher power in this iron, which is 60 watts rather than the 18 of previously, the higher power allows larger joints to be made. You've got more heat, you can more capacity to put heat into a joint, so larger joints become much more usable. This iron comes with a stand. This is a butchered together stand. This is a little bit of Antex, a little bit of the station, and a really old sponge that I've had for probably 2 or 3 years. I've got more on order, so that'll be replaced soon because that's quite disgusting now. But anyway, this is my go-to soldering system. Not the best I've ever used, but realistically for hobbyists, this is probably the best £30 you could spend. Okay, so we're moving on now to the solder itself. Now there's lots of types of solder that you can use out there. You have the Chinese suppliers, the eBays and the likes, where you can buy solder of unknown origin. I would strongly recommend against those. The solder that I use, for many years I used a 60-40 solder that came from Rapid Electronics in the UK. That's 60% tin and 40% lead. Now, lead's not that great a thing nowadays. Your manufacturers aren't allowed to use it in general, but as a consumer, as a home hobbyist, I still strongly recommend you use this type of solder in general. That is leaded solder. This is silver solder. This is a different formula entirely. This silver solder I've had for quite some time. The main reason that I would not recommend silver solder is, with it being lead free, it can be very much more difficult to get a flowing solder joint. The solder tends to melt at a higher temperature, so if your soldering iron's a bit low powered or inadequate for whatever reason, you may struggle to make a good joint with this. Even experienced people with many years experience quite often will recommend not going near silver solder unless it's really essential. Personally, I have this in case I need it for any particular job, but I do not use it. I have not used it for quite some time. Moving on to my favourite solder at the moment. This is Wharton Metals. It's instead of being a 60-40 solder, they changed the percentages very slightly. So this is like a 63-37. So realistically, let's just call it a 60-40. Very similar. This one has 2% flux. We'll cover that in a second. And this solder is my personal favourite. Much thinner, nicer for electronic components and work. It can be annoying because you need to flow an awful lot in if you're doing larger joints, but this is like a 0.7mm. This I think is a 1 point something millimeter. In general, I would suggest going for something like a 0.7mm, unless you're doing huge joints and large work. But for most electronic, this is nice. 22 gauge, 0.7mm. I recommend a 60-40 or a 63-37 lead based solder. This is the one that I personally choose to use. I've had this for a few months now. Very little if it's been used. A solder roll like this would cost about £20 and would probably last you 2 or 3 years under fairly heavy use as a hobbyist. A small roll like that you might get a year out of, and that's going to be £5. Just take it how you want, really. If you know you're going to be into electronics for a long time, buy a larger roll. I quite often decant it down into smaller rolls, and that's exactly what I did here. This is my daily solder. This is one of the Rapid Electronics rolls, which became empty after quite some time. I've rolled some of the 63-37 onto it, and I've also got some desolder braid here. Desolder braid, we'll come on to that in a few seconds. So, desoldering braid. This is my favourite solder, as I've just mentioned a second ago, and this is a desolder braid that I have pretty much attached to my soldering reel. The reason for that is this is really nice and useful to have around. Desoldering braid is good for taking the solder off a joint if you've put too much on there, or if you need to remove a component. The brand that I use, it's a cheap brand that comes from eBay. I'm not going to say I recommend it. It's not ideal. The main thing that I think this solder has an issue with is that there's very little in the way of flux on it. So you can be putting this onto the joint and trying to remove solder, and it just won't flow. The flux is there to help the solder flow, and obviously these should be impregnated with flux. It's usually pretty poor, to be honest, on this brand. The braid works perfectly if you add your own solder flux, and that is absolutely what I do. I have quite a lot of flux that I decant out into little bottles. I've got it in different manner and different styles. This is the liquid flux that I use. Again, it's just a fair... try that again on video. This is a liquid flux that I use that it's literally just a liquid. It works very well. I do like this product, but as you see, it is more just a liquid than anything else. And when you're using this braid, if you drip some onto this, it will soak into the braid, and then you will end up with braid saturated, and that will take solder joints apart really quite easily. It will remove solder really easy. For other situations where I need desolder braid, desolder braid? Not desolder braid, solder flux, I will quite often move on to this. Now it's called soldering paste. It's basically flux in a slightly more solid form. So this flux is a paste this time, so it's like a wax. It is good. I like this product. If you need to put some on a joint to make it stay there while you work, and you need a little bit longer working time, you can put a little blob of this on the solder joint, then go in with your soldering iron and your solder, and this will melt. It will put lots of flux on the joint, and that will help. Again, we'll come back to flux and its reasons a little bit further down the video. But I like this product. I don't use it a huge amount, but when you get to a position where the liquid flux just isn't quite cutting it and you need something a bit more heavy grade, I prefer this. Again, additional flux shouldn't be something you're using on a daily basis or a joint by joint basis. It's there for specific situations more than general use. Okay, so we're moving on now to general maintenance for your soldering equipment. I'm going to jump straight into the cleaning of the solder tip. When you're working away, excess flux, excess solder will build up, and it'll end up just as a mess on the tip. There's various ways of cleaning that off. I personally prefer the sponge, as you can tell, because it's been heavily used for a long time. You put a little bit of water on this sponge, and when your soldering iron's on and you wipe this, it cleans the tip and removes all of the excess flux and solder. Some people prefer to use this brass brush. I have the brass brush. I don't tend to use it. Okay, so I've got the soldering iron on now. This is going to be warming up. You'll see here that the tip has quite a large amount of solder on it. Now that is definitely the way I prefer to leave the tip when it's being used. Let me just fix the focus on that a little better. There we go. So the little blob that I leave on the end here, it helps keep the actual tip protected underneath that coat of metal, and that will help keep the tip in better condition. Obviously it's old solder, it's got no flux in it now, so you have to clean that off when you're about to solder. So we'll try this brass brush. Not my personal favourite, as I say, but you can see the tip's quite dirty there, big blobs of solder on it. Now the tip is much cleaner, it's shinier, it does quite a good job. I have no major problems with that work at all. I'm just going to grab some solder. I'll just picked up my Rapid 60-40 roll. I'll put a little bit on the tip here and then wipe it off with the sponge. The difficulty with the sponge, and this is why a lot of people don't like it, is sometimes you end up with a residue on the tip that just doesn't want to come off. but as long as the actual main surface itself is clean, the excess that's around it is not too much of a trouble, but you can see there is some excess around. If I go into the brass brush, it takes it off quite nicely. However, I still prefer the sponge on a daily basis. Whenever I'm soldering, I'll add some solder on and whatever, I'll do the joints that are required. As soon as I'm finished with that, I'll typically just wipe the sponge a couple of times and put it there. When I'm about to make a new joint, I'll quite often give it a quick wipe, make sure it's nice and clean, and then I'll add a little bit of solder, and then I'll go into the joint. Notice as I add a little bit of solder, you should add the absolute minimum. It's more just checking you've got a little bit of liquid there and checking that you've still got the temperature that you need. You're not applying the solder to the tip for the purpose of soldering. You're adding it to the tip just to confirm you're at temperature and to get a little bit of liquid on the tip. We'll come back to the process and the principles of soldering in a minute again. Okay, so we're going to move on to preparing your work for the soldering itself. So if you have a little circuit board, I've got this piece of Vero strip here that I would quite like this thing for prototyping. And let's just say you've got some resistors, which I have, funnily enough. This board is very matte coloured. It's been out for a long time, it's all oxidized. The copper is going to be extremely difficult to solder onto. What I'll quite often do is either just run a steel wool brush over it to shine it up, or I have this fiberglass pen. This fiberglass pen you can just run out as much as you need. Obviously you only need a tiny little bit, and what I'll usually do is just clean the board in the area that I need it to be clean, and it'll be much shinier, much easier to solder onto. Again, everyone's got their own varieties of this. Excuse the camera vibrating around as I wobble the desk. But for small amounts like this, if I was doing the whole board, I would definitely be using just standard steel wool. Like a kitchen scourer steel wool. It doesn't need to be anything fancy, but this would be the first thing I would try to bring the board up to a gloss finish. And here we are as a quick demonstration. Here's a steel wool kitchen scourer. We'll just use that to clean part of this board now, just so we can get a feel. Excuse the camera bubbles again. So you should be able to see the difference in the board here. We have the plain copper itself at this side, the first few tracks, and then we have the corroded, oxidized side over there. You probably can solder onto this, but it's going to be extremely difficult. I'm leaving half the board oxidized as an example. We'll try soldering on that, but you should always try to clean up your board, especially if it's Vero board. Clean it up and get it good and shiny prior to soldering. It will oxidize over in a matter of days probably, so obviously just do this as you're about to use it, because there's no point in doing it well in advance. Okay, so we're about to start soldering here. I have some components, I have some clean and some dirty oxidized board. Let's just jump into part 2 where we're going to actually do the soldering. See you in a second.